Okay, college trigonometry students, we move to our last section, which is the trigonometry of right triangles, something that we often refer to as SOHCAHTOA, something that you should have seen in geometry. And so we have identities for our trigonometric functions. Given a right triangle with an angle of theta, we have three sides that we talk about. First of all, we know that this is the hypotenuse, because it is the longest side of the triangle. It is across from the 90-degree angle, so that makes it the hypotenuse. Now, theta is made up of those two sides. So, because this side makes up the angle, it is next to it, and we call it adjacent. Adjacent means next to. So you can see that that angle is formed by that side and the hypotenuse. The one that is across from the angle, or opposite the angle, is called opposite. And so, sine of theta is the opposite over the hypotenuse. And you can see from this first part here, sine, opposite, and hypotenuse. So you can see the so and how it fits there. Cosine is the adjacent divided by the hypotenuse. So cosine is the adjacent divided by the hypotenuse. And tangent is the opposite divided by the adjacent. So you see tangent, opposite, adjacent. We won't worry about these. We really don't use them when it comes to right triangle trig. So it says find the exact value of the 6 trigonometric ratios of the angle theta in the triangle. Instead of doing 6, we'll do 3. First of all, we need the missing side. So we could set up 5 squared plus b squared is equal to 13 squared. So 25 plus b squared is equal to 169. B squared is 144, so b is 12. It is the length of a triangle, so therefore it cannot be negative. I will now label my sides. This is the hypotenuse. This is opposite theta, and this is the adjacent side. Again, adjacent because the angle theta is made up of these two sides. You can see that that is next to. So we have the sine of theta is going to be the opposite, which is 5, divided by the hypotenuse, which is 13. The cosine of theta is going to be equal to the adjacent side, 12, divided by the hypotenuse, which is 13. And the tangent of theta is going to be equal to the opposite, which is 5, divided by the adjacent, which is 12. And there you have it. In this case, you would also need to solve for the hypotenuse. 2 squared plus 4 squared is equal to c squared, or 4 plus 16 is c squared, or 20 is equal to c squared. Square root both sides, and you get 2 roots of 5 is equal to c. So 2 roots of 5. I will label the sides. This is opposite, because it's across from theta. This is the hypotenuse. This is the adjacent. So therefore, the sine of theta is equal to 4 over 2 roots of 5, or 2 over the root of 5, or 2 roots of 5 over 5. The cosine of theta is equal to 2 over 2 roots of 5, which ends up being the root of 5 over 5. And finally, the tangent of theta is equal to 4 over 2, which is 2. Now that you are hopefully clear with some of those pieces, let's work on actually solving for missing sides of a triangle. says solve the missing side of the triangle. We would like to find the hypotenuse, and we are given the opposite. Because you are given the opposite and finding the hypotenuse, we use sine. Sine of 42 degrees is equal to 9 over x. I will cross multiply. Take out my handy dandy calculator. Please make sure that your calculator is working in degrees. As you can see, the angle is in degrees. As I cross multiply, I get 9 is equal to sine of 42 times x. So I will take 9 and divide it by the sine of 42, and I get 13.45. For the next one, you can see this is the hypotenuse, and this is the adjacent side that I'm trying to find. So therefore, we can set up cosine of 63 is equal to the adjacent side x over the hypotenuse, which is 14. Cross multiply, we get x equal to 14 times the cosine of 63. Take out my calculator, 14 cosine of 63, and I get 6.36. And finally, in this example, I'm looking for the opposite, which is x, and I'm given the adjacent. So that would tell me I would use tangent. Namely, tangent of 27 degrees is equal to x divided by 9.4. As we cross multiply, we get x is equal to 9.4 times the tangent of 27. 4.79. We're going to skip these pieces and move in terms of application. I'll just try to speed things up for you. We would cover these in other years. But as we move to your worksheet, we will do a problem from each section together so that you understand. Section 1 is just like what we covered. You would label this the hypotenuse. You would label this the adjacent. And so therefore you have the cosine of 37 degrees is equal to 11 over x. As you cross multiply, 11 is equal to x cosine of 37. Go ahead and divide both sides by the cosine of 37. 13.77. And that would take care of you, take you through the rest of this piece. Now, what happens if we are looking for an angle? Well, set it up just like you normally would. You are given the hypotenuse and you are given the adjacent. You're looking for the angle. So we set up cosine of theta is equal to 12 over 13. The way that we find the angle is we undo cosine. The way you undo cosine is not by pressing cosine. You press second cosine, and see you get cosine inverse. That doesn't mean 1 divided by cosine. That means undo cosine. So it gets rid of the cosine and leaves you with theta. You just got to type in the 12 over 13, and that will then tell you the angle. So the angle is 22.62 degrees. So when you're solving for an angle, use the inverse operation. That should take you through problem 10. And then it says to solve the triangles with the following condition. So I will do example 1 and example 2 with you, and then we will be done. You always know that angle C is going to be the 90-degree angle, so label it 90 degrees. B is 32. Looks like that one's slightly smaller, so I'll call that 32 degrees, and we'll call this A. So, all right, B is 32 degrees. Now, the most important part is as you label the angles and the sides, the angles are the capital letters. The sides are the lowercase letters. So side A, side B, and side C. Side C is 8. Okay? So side opposite corresponds. So you can see that side A and angle A meet together. Angle B and side B They're directly opposite from each other in that way, and angle C and side C, again, you can see that they're opposite there. All right? So big letters, angles, small letters, sides. So we want to find the missing pieces. Finding this missing angle A is easy because all the angles must add up to 180. So if you had 180 minus 90 minus 32, you should get 58 degrees. That was easy enough. You also know that side C is 8. Now you can choose whether you'd like to find A or B. That's up to you. I would like to find side A. I want to find side A. That would be the adjacent side of 32 degrees, and C would be the hypotenuse. So I'm going to use cosine. The cosine of 32 degrees is equal to, you have the adjacent A divided by the hypotenuse 8. Or if you'd like to find B, you could set up sine. Sine of 32 degrees is equal to B divided by 8. Either way, you will be finding A or B. You can see now that as I solve, I have 8 times the cosine of 32 degrees, and I get 6.78. If you take 8 times the sine of 32, you get 4.24. Now, if you didn't want to set up 2 trigonometric functions in order to find A and B, you could have just found one and used the Pythagorean Theorem as well. If you notice, 6.78 squared plus 4.24 squared should be equal to 8 squared. It's a good way to check your answer, make sure that it works out. 6.78 squared plus 4.24 squared. And sure enough, because we rounded, we didn't come out to exactly 64, but you're very close. Example 2 is different because you do not have an angle. The short side 5, we'll call that A, so we'll call this A right there. I'll call that 12. Whoops, sorry about that. Wait a minute. Yes. Yep, that'll be B, and then C is our 90-degree angle. Sorry about that hesitation. So we know that this is side C here. So we have side A is 5. We have side B is 12. And we know angle C is 90 degrees. Angle C will always be 90 degrees. Well, now that we are given 2 sides, you can go ahead and use a Pythagorean theorem. 5 squared plus 12 squared is equal to C squared. Or 25 plus 144 is equal to C squared. Or 169 is equal to C squared. Square root both sides, and C is equal to 13. Now you can find angle A or angle B. It's up to you. I'm going to focus on angle B. If I focus on angle B, this is the hypotenuse, this is the opposite, and this is the adjacent. And you could really set up one of 3 trigonometric functions to find that. You could have the sine of B is equal to the opposite, which is 12, divided by the hypotenuse, which is 13. Or you could set up cosine of B is equal to the adjacent, which is 5, divided by the hypotenuse, which is 13. Or you could set up tangent of B is equal to the opposite, or the opposite, which is 12, divided by a hypotenuse, which is or divided by the adjacent, which is 5. So either way, you'll get the right answer, and I will show you. Again, as you're solving for an angle, you don't press sine, you press second sine. So second sine of 12 divided by 13, notice that you do get 67.38. If you were to do second cosine of 5 divided by 13, you can see you also get 67.38. And if you did inverse tangent of 12 divided by 5, you can see again, you should get 67.38, and you do. So angle B is 67.38. They must all add to 180. So 180 minus 90 minus 67.38. You do get 22.62 degrees. So that's how you solve triangles. So just to cover again, there you have those couple problems to work with, as well as these. It starts off with just finding a missing side and using your inverse operations as well. So we will take questions on that on Monday and Tuesday. Tests next week, Wednesday or Thursday, depending on which day you are. I can't wait to see you in class. Have a great weekend.